So, you've got a machine learning model. It's trained, it's tested, and it's ready to go. But how do you actually get it from a file sitting in a registry to a live service that's making the business real money? Well, today we're going to follow that exact journey, taking a model from the safety of its home right into the wilds of production.
Look, a trained model is all potential. It's a really powerful algorithm for sure, but as long as it's just sitting there on a server, it's not generating a single cent of value. The real challenge, and honestly this is where MLOps truly begins, is turning all that potential into a rock-solid, reliable service that actually makes an impact. And our journey starts right here, in the MLFO model registry. Think of this as our source of truth. We're looking at the ShopSmarts churn model, version 3.0. We can see it's been validated, it hit a solid F1 score of 0.75, that's how we measure its accuracy, and most importantly, it's been promoted to the production stage. It's officially got the green light.
See, yeah, that is the million-dollar question, isn't it? And the very first choice we have to make is where it's gonna live. This decision right at the beginning is going to set the stage for everything else, how it scales, how reliable it is, and whether we can update it later without, breaking everything.
For a long time, the easy answer was just throw it on a virtual machine. Simple, sure, but also incredibly fragile. I mean, if that one single machine goes down, your whole service is gone. The modern, truly production-grade way to do this is with something like Azure Kubernetes Service, or AKS. It's a system designed from the ground up to handle these exact problems.
So let's talk about what that really gets you. And what's amazing about this slide is what this number means in the real world. AKS offers a 99.95% uptime guarantee. You do the math, and that works out to less than 4.5 hours of downtime per year. For a service the business depends on, that's absolutely non-negotiable.
So how does it pull off that kind of uptime? Well, it's all about getting rid of single points of failure. Your service isn't just running on one computer. It's spread out across a minimum of 3 separate server nodes. So if one of those nodes decides to take a coffee break, the other 2 are still there, handling all the traffic without missing a beat.
And this is where the real magic is. Picture this. It's Black Friday, and your website traffic just goes through the roof. Instead of pagers going off and waking up an engineer, AKS just sees the spike and automatically spins up new copies of your model's API. It does it in about 30 seconds, and when things quiet down, it scales back down. That is true elasticity.
Now, to get our model running on a system like Kubernetes, we can't just have a bunch of Python scripts. We have to package it all up into a standardized, self-contained unit called a container. You can think of it like a perfectly sealed box that has our application and everything it needs to run. That way, it works the exact same way no matter where you put it.
And creating this box, the process we call containerization, is a pretty straightforward 4-step deal. First, you code the API itself. Then you write what's called a Docker file, which is basically just the recipe for building your container. You use that recipe to build the container image, and finally, you push that finished image up to a private, secure vault like the Azure Container Registry.
Okay, so our container is built, it's safe and sound in the registry, just waiting. The next big step is to hand it over to Kubernetes and basically say, here, run this and keep it running for me no matter what.
So first things first, our container doesn't just run on its own. It runs inside something called a pod. A pod is the smallest, most fundamental building block in the entire Kubernetes universe. It wraps our container, gives it a network address, manages its resources, the whole shebang. For our API, it's simple. 1 container per pod.
But what happens if a pod crashes? Well, that's where a deployment comes in. A deployment is kind of like the manager for our pods. We tell it, hey, I always want 3 identical copies of this pod running. And if one of them fails, the deployment just automatically creates a new one to take its place. It also lets us roll out new versions of our code with 0 downtime.
Okay, last piece of the puzzle. Pods come and go, right? So their individual IP addresses are always changing. That's a problem. To fix it, we create a service. A service gives us one single, stable IP address that never changes. It acts like a smart traffic cop, directing all the incoming requests to whichever of our pods are healthy and ready to work.
So look, getting the model up and running is huge, but it's only half the battle. To be truly ready for production, especially in a big company, you have to fortify it. It's got to be secure, it's got to be compliant with regulations, and you need to be able to see exactly what it's doing at all times.
Security first. You can't just leave an API endpoint wide open on the internet. That's a recipe for disaster. We lock it down using OAuth 2,
which is the industry standard. This whole system makes sure that only authorized applications with a valid temporary token can ask our model for a prediction. It's all about protecting the model and the data.
Next up, compliance. Laws like Europe's GDPR have totally changed the game for AI. It's not enough anymore for a model to just spit out a prediction. We legally have to be able to explain why it made that specific decision. This is called the right to explanation, and it is a big deal.
So, to meet that legal requirement, ShopSmart uses a cool technique called SHAP. It's based on game theory, and what it does is it can take any single prediction, like this customer is going to churn, and it breaks down exactly how much each piece of data, like their last purchase date or number of support calls, push the model toward that final answer.
And finally, observability. We need to watch our service's vital signs in real time. By using tools like the Prometheus operator right inside Kubernetes, we can automatically track the key metrics for our API. Things like latency, how fast is it? Throughput, how many requests is it handling? And the error rate. This tells us instantly if something's starting to go wrong.
All right, so we've built this really sophisticated, secure, observable system. That's great, but this is the real question. What did all that technical effort actually do for the business? What's the bottom line?
Well, by accurately flagging customers who are about to leave, allowing the marketing team to step in, this system helped slash the customer churn rate from 15% all the way down to 10%. That 5-point drop, it translated to a whopping $3.75 million in saved revenue every single year.
And remember that auto-scaling we talked about? During huge sales events like Black Friday, the system saw 10 times the normal traffic. And thanks to Kubernetes, it handled that massive spike perfectly, scaling up and back down all on its own, without anyone lifting a finger.
Okay, brace yourself for this last number. You take those millions in saved revenue, and you compare it to the relatively small cost of the infrastructure, and the total return on investment comes out to 119,650%. Yeah, it's pretty mind-boggling.
You know, this whole journey from the registry all the way to a running, monitored service, it really highlights one thing. MLOps isn't a project you just finish. It's a continuous cycle of deploying, watching, and improving. Which kind of leaves us with one final thought to chew on. In a world where data is always changing and customers are always evolving, is the job of managing a model ever really done?